So in this lecture, we're going to be talking about the remainder theorem. And basically that says, the definition of it was if f of x is equal to x minus h times q of x plus r. Okay, that's what it's saying. It says where q of x is the quotient and r is the remainder. Okay, so we're going to just work with this a bit and help us get to a more useful definition. So for when x is equal to h, this is a special case of the remainder theorem. So for f is equal to h, what's going to happen? Well, you're going to have h minus h times q of h plus r. What's going to happen here is h minus h is going to be 0, and anything times 0 is just 0. So then we're left with the result that f of h is equal to r. Okay, so then we have this case here, right? So we say f of x is equal to x minus h and times q of x plus, well, we have this f of h because we proved that f of h is equal to the remainder. So here we can say that if a polynomial is divided by x minus h, the remainder is going to be f of h. Okay, this, I know it sounds a bit abstract, but this is just a proof for it. It's not essential that you understand this one, or can reproduce this. It's just so you understand where the expression comes from. So I'm going to go and do an example now. So find the quotient and the remainder when f of x is equal to 3x to the power of 5 minus 2x cubed minus x squared plus 4x minus 6 is divided by x plus 4 and express the result in the form of f of x plus 4 plus times qx plus f of h. So we want to find the quotient and the remainder. That's basically what the question's asking us to do. So we're going to set up our synthetic division over here. Okay. And here our divider is x plus 4. So x plus 4 equals 0. So x is going to be negative 4. Negative 4 over here. Right. Then you have x to the 5, x to the 4, x to the 3, x to the 2, x to the 1, x to the 0. So what are the coefficients here? We've got 3, and there's no x to the 4 coefficients, that's going to be 0, and then that's going to be negative 2, it's going to be, for x squared it's negative 1, for x it's 4, and for x to 0 it's negative 6. So I'm going to be using a calculator for this. You're not expected to know this in your head, but just follow along. So this is 3 plus 0 is 3, 3 times 4 is negative 12, negative 12 plus 0 is negative 12, negative 12 times 4 is positive 48, plus negative 2 is 46, times negative 4 is negative 184, plus negative 1 is going to be negative 185, times by 4 is going to be 740, plus 4 is going to be 744, and then times by negative 4 is going to be negative 2976, plus negative 6 is going to be 2982, negative 2982. Okay, so going back to the question, express the form of f of x equal to x plus 4 times the quotient plus the remainder. So this is going to look like this. F of x equal to x plus 4. Right, and remember that this is going to have dropped one order. So this is going to be 3x to the 4 minus 12x cubed plus 46x squared minus 185x plus 744. Then you're going to have at the end minus the remainder, which is 2982. So that's your final answer here, and your QX is here, and your f of h, or your remainder, is over there. So to here, and that's your thing there, just to kind of help you visualize it for you.